Yesterday we graphed equations that were in slope-intercept form. Today we're going to take information about lines and use them to write equations in slope-intercept form. And when we do that, we're going to need to be able to find values for m and b. Now if you look at the problem we have in front of us, we want to write the equation of a line passing through the point 3,5 having a slope of 8. We can identify some of these things in the equation. The slope, 8, is m. The 3 and the 5 are parts of points, and points are made up of x and y values. So what we're going to do is we're going to plug those in for y, m, and x, and notice we'll have one unknown left, which is b. And we'll solve for b. So in this case we have 5 is equal to 3 times 8 plus b. 3 times 8 is 24. Plus b is equal to 5. Subtract 25, or 24 from both sides, sorry. And we end up with 19 of the negative type. And if we want to write the equation, we leave y as is. We fill in the value for m, which we know is 8. We leave x as a variable. And we fill in the value for b, which is negative 19. And y equals 8x minus 19 is the equation of that line. This next example is similar. We know we have a slope of negative 8/3. We have an x and a y point. So we set up our slope-intercept equation of y equals mx plus b, where we plug in negative 8/3 for our slope. X is 6. Y is negative 5. We're going to need to once again find our b. 8/3 times 6, the 6 and the 3 reduce. So I have 2 and 8, which is negative 16, plus b equals negative 5. Add 16 to both sides. End up with 11. It's equal to b. So our solution, y equals negative 8/3 x plus 11. So in this next example, you'll see that we're trying to find the slope-intercept equation of a line that passes through 2 points. And we aren't given a slope, but we've already gone through the process of finding a slope given 2 points. If we take difference of the y's, or y2 minus y1 over x2 minus x1, we can find the slope m. We just have to determine which is which. So let's call this x1 and y1, and x2 and y2, and plug into the formula. So in doing that, we have 7 minus 5 over negative 2 minus 3, or positive 2 over negative 5 is equal to our slope. So now, substituting into y equals mx plus b, you'll notice we have an m value of negative 2/5 for m, but we need an x and a y. And in this case we have 2, but it really doesn't matter which one we use. We can use this xy or this xy because both of them go through the line. I'll use the first one where I have a 5 for my y and a 3 for an x, and then we'll solve for b. So in this case you'll notice there's no reduction here, so I'll have negative 6/5 is equal to 5, and then I have a plus b over here. Now I'll have to add 6/5 to both sides, and if I want to I can clear a fraction. If I don't want to, I don't have to either. I'm going to add 6/5 to both sides, and I know 6/5 is 1 1/5, and if I add 1 1/5 to 5, I get 6 1/5 is equal to b. So I can say y is equal to negative 2/5 x plus 6 1/5, and I'll take that. Similar problem next. This one will have a twist in it though. Let's take a look at it. Again, we have 2 points that the line goes through. So I'll take y2 minus y1 over x2 minus x1. Here's the first point. And we'll plug in to our equation, y2, that's -8. And from that, we'll subtract 6 over 7 minus 7. Now notice what happens here. I have -14 over 0. You can't define anything by 0 or divide anything by 0, so we get no solution on this. So this has actually no slope. Now, let's take a look at what's happening here. Here's our line, and if I go over to 7, 6, that's somewhere over here. 7, -8 is somewhere here, and our line goes through that. This is a vertical line, and we know vertical lines have special equations. Every point on a vertical line has the same x value, and that's how we describe our equation. Our equation is just x is equal to 7. So this was a special case. In this problem, we've got a word problem that talks a little bit about writing a linear equation. So they tell us that during 1 year, the cost for gas is $3.20 on the first month of, or on the 1st of June, and $3.40 on the 1st of July. And they want us to write a linear equation to predict the cost of gas for any given first day of the month. And they want us to use 1 to represent January. So what they're telling us is we have some points we have to consider. Since this is June, June is the 6th month, and we have a gas value of $3.20. I'm just going to use pennies. And then July, which is the 7th month, is $3.42. So what I can do, this is just like the other problems we've done. We've got really 2 points here, and I can find, so all we really have to do is find a slope by taking 342 minus 320 over 7 minus 6, which gets us our slope, and that ends up equaling 22. So I have y equals 22x plus b. Plug in our points, we'll take 320 equals 22 times 6 plus b. 22 times 6 is equal to 132. So 132 plus b is equal to 320. Subtract 132 from both sides. We get b is equal to 188. So y equals 22x plus 188. And that's our equation. So in this example, we have a population in 2007 and a population in 1990. And we assume that the growth is constant, which means the slope is constant. And t represents the number of years after 1990. That's important. 1991 would represent the number 1 for t, 1992, etc., etc. So 1990 actually represents the 0 year. And the population is the y value. So in 1990, I have 123,000. And in 2007, which is 17 years after 1990, I have 215,000. Again, we're going to find a slope by taking 215,000 minus 123,000 over 17 minus 0. And that will equal our m value. So 215,000 minus 123,000 is equal to, what is that, 900 or 92,500 all over 17, and that's going to equal m. And 92,500 divided by 17 is going to equal, since we're talking about people, we'll go 5,441, and that's our m value. So we have y equals 5,441 x plus b. Now this is an interesting problem because we know we have a point where the x value is 0 and we have a y value. This is really our y-intercept. So I don't even have to go and calculate it. I can just say my equation of the line is y equals 5,441 x plus 123,000.